channel, and today I'm going to be doing the editorial for task L, Deque of the AtCoder DP contest. Okay, so you have two people playing a game against each other. They're given like some sequence of numbers, and basically each player can either remove an element from the beginning or end of like whatever the current array is, and you earn that amount of points, the amount of points which is like the value at that index. Okay, and if X is the score of Taro's and Y is the score of Jiro, so Taro's the guy going first, then the first guy is trying to maximize X minus Y, while Jiro is trying to minimize X minus Y. Okay, and so you're trying to find, if they both play optimally, find the resulting value of X, Y. Okay, so let's look at that real quick. So the guy that goes first is trying to maximize X minus Y, and the guy that goes second is trying to min X minus Y. Okay, so for this guy, X is the, X is basically, so X is what the first guy's doing and Y is what the second guy's doing. But if I'm, right, so let's say if I'm first, X is me and Y is the opponent. But for this guy, you're trying to minimize this X minus Y, where X is your opponent and Y is me. So if I have like a new, thing, right, where, you're trying to minimize this value, this is the same as maximizing X prime, where this is me, minus Y prime, which is the opponent. And this works if we say X, X prime is equal to Y, and if Y prime is equal to X, right? So essentially what we've done is we can see that both of these two guys, both of the opponents, are trying to optimize for the exact same thing. They have the exact same strategy. So all we're trying to say is, given some situation, right, with this array, given some situation, how do we maximize like the current guy's thing, right? And then I want to pick, the option that's best for me. Now when I take it away, now from here, my opponent's going to do something, right? Now from here, my opponent's trying to maximize like the same thing. So as we can see, the problem is boiling down to like the same problem, because after I go, the other guy is following the exact same thought process as me. So this way we can decompose the problem. So let's look at an example. So here we have 10, 80, 90, and 30. So the first guy is trying to maximize his score. If he takes 30, right? If guy 1 takes 30, guy 2 should take 90, guy 1 will take 80, or now, it's just this. So guy 1 will take 80, guy 2 take that, right? So now 2 has 100, 1 has 110. But let's say instead of taking from the right first, he takes from this side, right? So let's say 1 takes this guy. Then from here, either, 90 is the most, so, but either way, 2 won't be able to get to that. 2 might take this guy, 1 will take this guy, 2 take this guy. So in this case, 2 is 110 and 1 is 100. So clearly, this is the answer. All right. So now that we have this answer, let's see how we can reach to this from our realization from earlier. Now, in the most basic form, right, if you're just left down to 1, then, I mean, the decision is obviously clear. You just take that and you win, for that sub-problem. So if you're taking the full guy here, then what you're trying to do is you're trying to say, okay, if I take this, then the other guy is trying to maximize this, okay? But if I take this, sorry, the new color, if I take this guy, then my next guy is trying to maximize this, okay? So, given that I already have like these simpler subproblems found out, then for a given range, I and j, which is like, it's basically just some like subarray here, right? You take off from either one of the sides, so it's just going to be like some subarray basically in the middle here. The dp of this is essentially the max. So what this dp is going to find is it's trying to maximize the x minus j, and as I told you, it's the same for both people, right? So this is the only thing we have to figure out. So this is just the maximum of whatever ai is plus, or minus dp of I plus 1 of j, and a j minus dp of I and j minus 1. Okay, so the way this works is, I told you about, the prime whatever thing, right? So after I take my thing, this guy is trying to maximize his x minus his y, right? So if I'm trying to convert that to my thing here, right, I'm just swapping it around. So essentially, if I take, the a that I took, I'll just maximize it. I'll just do that minus x of the other guy, right, minus dy of me, because that's the situation from the other guy's perspective, right? It basically just reverses. So that's why we get that minus here, right? And from here, we can simply look at the dp, right? So I am trying to maximize, I can choose my first, right? And then after that, it's just what the other guy is trying to maximize, which is the exact same process. So that's all it's going to be. What you're going to start with is you're going to initialize all dpi's to basically like 0, right? Or like depending on your implementation, it'll either be 0 or it'll be like, or it'll be AI, right? All I'm trying to say is that if, the subarray is of size 1, you only have one option, and you just take it, because as it says in the problem here, each of the AIs are at least positive. They must be positive. And then all you do is you loop through each of these subarrays, and basically what you do is you like loop by the side, the length of them. So you just do dp, you basically do for I 0, which would be, or it'd be 1 to size n, for k, or let's just for the sake of matching with here, we can do k here, and then we do I, which is like the left. I start that from 1 n minus k, and then we do for j, which is the right, of I plus k, or sorry, this is wrong. J is just set to I plus k, and then you calculate this recurrence relation, right? Because obviously, once you pick which side to do, your next problem is a subarray of one size smaller. So this is how you need to iterate through to make sure that all of the previous problems are solved. So because we're doing this, essentially all we're doing is copulating the DP array, which is just n times n. So this would be O of n squared, right? Because it's constant time. And because n is almost 3000, this will work. So I hope you found this helpful, and thank you for watching, and I'll see you next time. Bye.